My name is Bercovici. I'm from Radware. I'm working at the OpenStack project for, I would say, about 2 years, starting from the Grizzly project. With me is Nati, Shalom.
My name is Nati, Shalom. You all know me, so we can skip that part.
Okay, so today what we wanted to discuss about is when the application, Nati is coming from an application perspective environment where orchestration and application node are the key. I'm coming more from the networking perspective where security and load balancing are the focus. And we wanted to talk today on what happens when the application and the networking are meeting. I'll give a short overview of networking and application, what changed, and then Nati will switch to what's the state of the nation in terms of orchestration system, HEAT, Tosca, and then we'll talk about what's going to probably happen in the future. So with that, basic definitions, okay? So usually when, as an application person, well, usually I'm used to, in my previous lives, I'm used to talk about tiers, right? So first I'm talking about the application, then I'm looking at the different tiers. There's usually the web tier, middle tier, database tier, which is fine. Then the next thing is thinking about the nodes, the members, right? They could be physical, they could be virtual. Again, nothing new here. So how many nodes do I need? What's the scalability points, etc. And this is still something that as an application, this is part of my design, my thinking. And then if we zoom into a tier, and again, this is still something that I will usually own as an application developer or as a DevOps. I will look at how the server is being constructed, what is connection point, NICs, what's operating system to put on there, for example, what's the IP addresses that someone gives me, my application, let's say it's the database, what is its layer for, which TCP port it listens to, and then the actual application code, right? And all of this is the things that as an application developer, as a DevOps, I will own, I will plan, and I will eventually automate or deploy, right? So the next thing is to think about is connectivity, right? And as an application owner, usually I'm just thinking about which tier needs to communicate with which tier. So for example, internet pings into the web tier, then middle tier, and then DB. And usually this is where life, this is where I would stop, right? This is where someone else needs to own whatever is happening there. So as long as I'm going to get connectivity between my different tiers and as long as they get some connection point, IP, etc., I'm fine. Okay, but where's the network in all of this? What does the other side do? Okay, the network guy. So usually, first thing that he needs to talk with me still about is there any concerns about broadcast or multicast requirement of the application, right? If there's such requirement, that might be something that would put some design constraints on how the network gets designed. So, for example, the database in the middle tier might need to share some broadcast domain because there's some discovery protocol going on. Or I actually want to have privacy or isolation between those domains. So then different broadcast domains and then maybe different subnets, okay? So this is the first thing, which probably most of us are still quite aware of. The next phase is, what are the networking services that needs to be consumed there, right? Do I need an IP address management system, DHCP maybe? What's the gateway? How do I define the subnet? How do I manage the DNS, the naming, and the resolution? Which is still, again, quite sometimes might applicable and applicative. And those are the layer 3 services. Then I'm starting to talk about availability concerns, right? It could be through the application. It could be using some things like a load balancer. So I might have like a load balancer handling the high availability of the database, or probably more so a load balancer that does a load balancing for the middle tier and the web tier. And that starts to be things that my network team will handle and place for me. And on top of that, there's the security, availability, scalability. All those things are on many occasions outside the scope of me as an application developer. I don't really think about them, but they are happening underneath it. And in parallel, there's the whole discussion of manageability. How all of this get managed? Does it require its own network? Does it have some additional networking services that are required, such as VPN, okay? Now, if we look at what is currently available in OpenStack, okay, as an API, we see that all the different aspects of the networking are available. So you could create a network, a broadcast domain. You could create a subnet. You could create the different network services such as routers, NAS, DHCP, etc. You could manage your network security through firewall and VPNs because you have firewall and VPN as a service. And all those things are usually being done by the network security manager, which are traditionally were done by security manager. And then the server, operating system, software stack, etc., were done by the application manager. And as I said, in OpenStack, you get a capability to manage the load balancer is kind of strange there because it does have its networking aspects, how it's connected, okay? But it also has the application-based capabilities, such as how the persistency is handled and other capabilities, which is kind of an issue on who actually manages. So, so far we've seen that there's aspects that are purely managed in traditional organizations by the network admin, and there are portions that are being managed by the application admin, but something is now changing, right? What's changed? Everything becomes software, right? Orchestration, compute, networking, everything now can be orchestrated. And as we can see in OpenStack, we have the capability through an API to create all those parts, meaning the networks, the subnets, the services, security ports, and all the layer 4 to 7 services, such as load balancer, VPNs, and firewall, okay? But the fact that all of this is available now creates a challenge because now you can actually do the delegation of responsibility, the things that your network admin done and your application on the same place, okay?
Yeah, so before I dive into the technical part of my slides, I would say that the experience of even writing those slides as someone who's coming from an application perspective was such that I was looking at that and I was saying, wow, there's a lot of network in my life and I didn't even know it exists. And for most part, for most of us, someone else dealt with a lot of those details. And the thing that is happening right now with the introduction of something like Neutron is very similar to the things that happen in the DevOps world when the data center becomes software-based. All of a sudden, application owners, one, need to know about operations, and second, they have the tools to interact with that and in a way bypass some of the operations duties and guide, and that raises a lot of questions, both technical, operational, cultures, and stuff like that. And I think it applies to network just the same because of the change that Shmuel mentioned. So in order to illustrate what are the capabilities that we have in our hands today, we'll start with two applications, and we'll take two approaches that are actually converging. One of them is Tosca-based, and the other one is heat-based, which is currently using a different format. We'll use a reference of an application. Those who've been in the Tosca example, pretty much the same thing. One of them is the WordPress, which is, if you like, the hello world for heat. And we'll see what are the network nodes or components that we're creating as part of the application deployment. Okay, so what we're basically taking is a full stack that includes the software stack, the infrastructure itself, which is the machines and stuff, as well as the network. In this specific case, on the database side, the MySQL, we have data networks that is specific, that is separate between the application and the database itself, and we have a public network that is the view outside of the application itself, and therefore you could see that there's we have additional components on the public-facing side, which is the floating IP and more different on the routers and some other things that will allow traffic coming out from the outside versus the database and application communicate directly only through private networks, and therefore they don't need those components. And this is basically how this looks like in a network topology view. This is if you go to the Horizon, the OpenStack dashboard, and you deploy the application, you'll see there is a tab that is called Network Topology. And if you go to the Network Topology, you would see those different networks. So we have VLAN for the application, and we have VLAN for the public facing. You could see that the green light is the application network that is public facing, and therefore have a link to the router on the left-hand side, where the data networks only connects the two nodes that are basically the web container and the database itself. So what we've done here is we created a topology, and we'll see how that topology looks like in a heat format, and deployed it. And because we have the network API in our hand, we could create the entire thing. So imagine the thing that we're experiencing right now. In one click, we're creating the network, the router, the VLANs, connect them to the right nodes, install the software, configure them, wire them together, and I'm getting a full, if you'd like, production environment in one go. That's quite amazing. Okay, this is quite amazing in all means, and as I said, there is more means to that than the actual technical side of that we'll talk later on. So just to give you an idea how that looks like, it's actually relatively readable. Okay, it's very verbose, but still relatively readable. If you read that thing, you would understand what's going on here. So we could see that there is an application network that is configured using a neutron component that is called network. And then there is a reference to a subnet. The subnet is the actual entity that we're working with. Would be the VLAN for the data and the VLAN for the public, and we're creating VLANs for each one of them, creating the DNS and a range of IPs that you don't really see here, the allocation pools, and some other configuration that we're making here, but it's basically following the Neutron API. So what we're getting here is something that Neutron has an API, a REST API, and then there is a configuration that is based in YAML that maps that API into a document that is more readable and more easier to change and create a full topology around it. So think about it as a way to view the API in a document model. That's kind of the basic idea. Now we're going to see a Tosca-like example. Just to give you one note about the difference between Tosca and Heat without going into the details of that, because there was a dedicated session for that. Heat was developed from the infrastructure upwards. Basically, it was a mapping of the Nova API and all the APIs and created a document model for that gradually evolved up the stack. Where Tosca came from a fairly different view. It came from an application view of the world. It says the world is built out of application, out of tiers, and all those stuff things, and infrastructure is something below that. And therefore, you'd see the change in semantics as a result of that. For example, there is much more emphasis on software deployment, and there is much more emphasis on relationship, and there is much more emphasis on how you glue those dependencies together and deal with software updates and stuff like that. But the ideas are fairly similar. So in this case, we picked the MongoDB and the node seller, which is a wine cellar example. And we're following pretty much the same steps. So we'll create the same type of networks and the same components. In addition to that, just to make things more interesting, we created also an additional network for the monitoring and logging network so that it wouldn't interfere with the database traffic and so forth. And the result, again, looks fairly similar. We see here that we have an additional admin network in addition to the data network and public network. Let's continue. This is how it looks like. I used, in the Tosca side, I used the Cloudify dashboard. So this is basically what Cloudify adds is the admin network, which basically creates a Logstash agent on each machine and do all the monitoring and logging, gathering of the data from the application, pulls that into the admin network, send it into an elastic search engine, and then creating two views, if you'd like. One of them is a topology view, so you could see a graph here of the topology that I saw in the YAML, in text, in a graphical view, and I can see the dependency and follow the installation and the creation of all the instances. So I can see the creation of the network, and then I can see the creation of the nodes themselves and how many of the nodes per table. And on the right-hand side, I have the event side. All the events that are flowing through the systems, going through the analytics systems, and going through the Elasticsearch database. And in that case, that feeds back the system to say if something wrong, take actions, and also stores the historical data. And the way it looks like, I think, is slightly more readable. We have a definition of a blueprint. In the same way, we have a definition of a network and a subnet. And the network type, as you could see, is, again, following very, very similar type of syntax. But the main difference is the relationship side. So you could see, for example, that I have a block that is called relationship that can say that this network connects, as you've seen in the arrows, connect to these networks and contains in the other networks, and I can reference also to the dependencies of one stack on the other. I can say, yes. Tosca is a moving target, and there is a definition of that in the last summit. There is a definition that is very close to that. Okay, so if you go to Tosca today, you'll still see something very close to that. If you go there tomorrow, it might change. So and that's an important point, and I'm glad that you brought it up. The world that we live in, and that's kind of the message that I have, is that Heat and Tosca are converging, but it's a moving target. Okay, so you can't really go to a place, whether it's even Cloudify or something else, find a standard, and then say, this is a standard, run it here or run it there, and it will work. But it will make the change very small. The change, for example, even today, to go from a Tosca model to Heat is much smaller than if it would go to the older version of Heat or the CloudFormation version of Heat. So there is a clear conversion, and there's still a work to make the migration, but the work becomes smaller and smaller and smaller as the standardization consolidate. And basically the message, as you've seen also in the other session, is that I think there is a large degree of acceptance that they should converge.
So the last interesting thing that you can do when you actually have automation is that you can take things that might have not been done manually and you can achieve them. So a nice thing that Heat has currently been able to do, and there's a nice example in the samples there, is adding AutoScaling and availability. So up until now, what Nati has shown is a solution that has an application, but without a load balancer. Heat actually allows you to add the load balancing capabilities. In that example specifically, using a Radware solution, load balancing as a service solution, when a tenant actually spin up the application VMs, you can actually specify that there is a VIP using the LBAS API. The end result would be that underneath the hood is going to get a load balancing pair dynamically provisioned and isolated for him without the need to pre-provision those instances. The VIP will exist there when there's a scale up. Go back one. When there's a scale up and a VM is added, one more. Okay, when there's a scale-up event and one VM is added, then part of the orchestration will add this VM, will configure the load balancing capabilities to distribute traffic to it, and when it goes down, it will remove this VM. The construct in Heat is that basically, I'm just listing this long, is basically you have the capability to define the conditions where an alert is raised, for example, being based on CPU loads, which are consumed from Salometer. Then you can define what is the scale up and scale down policy, meaning in that case, adding a VM and removing a VM. And then you also specify the initial configuration of the load balancer for the initial deployment. So in that case, when you're actually running this hot script, you're not just deploying the VMs, the front-end VMs, you also get the definition, meaning the load balancer, the pool, and the monitor is needed, and then everything else that needs to be monitoring this application, the triggers, and the events, meaning adding and removing another VM. So far, so good. But what we are getting here is that continuous availability is a challenge.
Yeah. So basically, I think that what we've seen so far is a typical example, relatively, say, simple example, but still there was a lot of work that we had to do on the network side and the application configuration side, even for a simple use case. Obviously, there is a question: is that ready for mass production, and is it ready for large-scale deployment, for real production deployments? Is that ready today? Is that ready for other times? And something that I wanted to use, and usually the things that you need to think when you move into production is really the continuous availability things. Meaning, for example, how do I create a deployment that will make sure that one database node runs in one availability zones and the other one is in another availability zone, so if they fail, if the data center fails, I don't lose both ends of the database in one time. How do I wire the tenants so that I can have the same network connecting between the two databases in this specific case? How do I make sure that the block storage, for example, is allocated in the right place? So, for example, if I reprovision a database, and I call the API to create a storage, I need to make sure that the API would remember which database node fell in which zone and will create it in the same availability zones as the new database that I'm creating. So there is a lot of dependencies in that process when I'm trying to get to a real production use case that I need to deal with. And one thing that we did in this specific case with a case study with HP Print, that was, HP Print was actually running on Amazon. Before we integrated with them. And they were heavy users of Chef. They're doing continuous deployment basically, so they have providing print as a service for their customers. And they were happy with Amazon. Obviously, HP came up with their cloud, which is OpenStack based. And business-wise, it makes sense to move their operations from the Amazon environment into the OpenStack environment, the HP OpenStack environment, that is. And they needed a way to one, mitigate some of the gaps that exist today in terms of auto-scaling and some of the policies, and second, a way that will plug into their existing Chef artifacts, and in addition to that, will take advantage of all the networking capabilities and APIs that exist in the OpenStack environment. So that's kind of what they ended up doing, and again, what you could see is a real live picture from their dashboard, from their Horizon dashboard. So this is a real operations that is currently running, in this case, of HP Print in HP OpenStack, and is using that automation of application configuration, application deployment, and network configuration, using the latest and greatest of that OpenStack can offer, in that regard to actually deploy things in a production type of environment, and includes all the things that I mentioned. So this is actually my secret project. Still working on it, if someone can volunteer. No one can contribute code to that, though. Can, but who knows what shape that would look like.
Some code dumps.
Exactly. Code dumps, yes. Let's move on. So the good news is, again, is that in terms of the orchestration capabilities, in order to deliver something like HP Print today, we had to do some, if you like, proprietary work. Whether it was through the integration with HIT and Tosca, and as I mentioned, there is a lot of work, those who've been in the last summit, there's a lot of work to converge the two things, so we could do more and more of that using the standard or using the base OpenStack API rather than implementing things on top of it. The same goes with Tosca, so both ways comes close. The Tosca guys coming with a new type of DSL for their models and stuff like that, and also what we realize is that the right way to plug into that play is actually integrate Cloudify, in our case, with HIT. So rather than implementing yet another orchestration, if you're running in OpenStack, we can consume HIT for the infrastructure provisioning, for the network provisioning, for the machine provisioning, for a lot of the things that are very good in HIT. Why should we reinvent the wheel in that regard? And there is a project that we're doing to do that type of things, and luckily, this has actually become much more easier today.
Another interesting future project is, which is done, I think there is going to be a part of it also available in OpenStack Neutron, is what is called group-based policy. Group-based policy is the notion of how would a network operator and an application owner be able to actually specify the joint requirement in a language that is more understandable by application. So instead of talking about network components such as broadcast domain, layer 3, etc., group-based domain more addresses the fact that you have a group of nodes that needs to connect with each other or don't need to connect with each other, and how they should connect with each other, which kind of more make the connectivity of your application nodes more logical. It also touches one of the things that was discussed here is delegation of responsibility. When you use an orchestration tool such as Heat, or at least for now Tosca, everything that you are doing, which includes the network deployment and the application deployment, are being included on the same orchestration. On many organizations, that's actually two different expertise sets. The people who manage the networks and deploy them and the people who manage the application. The idea of GBP is that you could actually get to a delegation of responsibility by allowing the network administrator to specify the policies and the right way to deploy the application from their perspective, while allowing the application owner to just specify connectivity. So everything that we were talking about here is also in this presentation, which will be available, I think.
It's already available.
Right. So we have the Heat example and the Tosca-like examples available if you want to play with. The actual Heat example is actually available from Git. And everything else is also there. Any questions? We're on time.
Yep. So any questions? No questions? Thank you.